as I've mentioned previously, there are many different versions of formulas to do correlations. And so the one we have learned how to do, the only one really that we need to know how to do, is our Pearson R. But we're going to talk through just a few other formulas. We're not going to look at the formulas themselves, but the names and why we would pick them. Again, most of the other correlation coefficients, they just require a few extra steps, but it's mostly that really the same formulas as the Pearson. It's just what you've got to do with your data to get it Pearson ready, if you will. But they call them other names because they're representing other types of data. So Pearson R, particularly in social sciences, that's the king of all correlation coefficients. That's the most common. Probably the biggest runner-up to that would be what we call the Spearman. Sometimes called the Spearman rho, like our rho for our Pearson R, Spearman R instead of a Pearson R. So why would you use a Spearman instead of a Pearson? There are two basic reasons why you would choose to use a Spearman. You would use a Spearman instead of a Pearson, A, if your data was at the ordinal level. There's a flashback for you, right? Nominal, ordinal, interval, ratio. So nominal just names ordinal, names with a ranking, but we don't know how much more or less. Small, medium, large, first, second, third, those sorts of things, right? Freshman, sophomore, junior, senior, we know is more and less, we don't know exactly. So if you've got ordinal data, we want to use the Spearman approach. The other reason you would use the Spearman is if you knew you had a curvilinear relationship. Remember, the Pearson is really only built to do linear forms. But if you did a scattergram and you looked at your data and you said, oh wow, this has got a big legit curve in it. Remember, it can curve in any way, a U, a C, an upside down U, a Z, an S. If it's got a big bend in it, if we see it's curvilinear, we want to use the Spearman. So if we have data that's at the ordinal level, or if we are expecting a curvilinear relationship, we want to use a Spearman instead of a Pearson. Our next choice we call a point biserial. A point biserial correlation is what you would use if one of your two variables, just one of your two variables, is dichotomous. When we say that something is dichotomous, that it's a dichotomy, we mean it's one of two choices. So if we were looking at biological sex, male versus female, that's dichotomous. If we were looking at smoking status, smoker, non-smoker, that's dichotomous. If we were looking at high school graduates, graduate or not graduate, that's dichotomous. On a med, off a med, dichotomous. So if there's only two choices, it's either A or B, one or two. So if one of our variables is dichotomous, we would want to use a point biserial to make our calculations. Our final option that's in the book that we'll discuss here is called the phi coefficient. We use the point biserial when one of our two variables is dichotomous. We do the phi when both variables are dichotomous. So if both of the variables, both variable x and y, if they're both dichotomous, if they're both yes, no, black, white, up, down sorts of options, then we want to do the phi. The way I remember the difference between these two is point biserial, a point, one dichotomous variable, phi coefficient, both of them are dichotomous. So those are all of our alternatives to the Pearson R. Again, there are a bunch of others built for different types of data, but in the social sciences, these are the three most common alternatives to Pearson R. So with that, everybody, we are done with the chapter on correlation coefficients. So a lot more vocabulary than you're used to lately anyway. So make sure you study this vocabulary like the olden days of, say, chapter 1 or 2, where it was more words than math, because this chapter is way more words than math. And there we go. As always, if you've got questions, you know what to do. Hit me up with an email or a Canvas message, and let me know what you need help with, and I will be happy to assist you. And there it is. So the last thing that you'll be looking at from here would be the lab for this chapter, for your lab answers. And then it's down to your final exam. Remember, your final exam is only the last 3 chapters. So it's just 12, 13, 14. Independent measures ANOVA, repeated measures ANOVA, and correlation coefficients. So it's not a final exam in the cumulative sense. It's not chapters 1 through the end. It's just the last 3. It's just another test on the last 3 chapters. We'll run it the same as all the previous online tests we've been doing this remote learning session. So if you've got questions about anything related to the exam, make sure you hit me up with those questions as well. All right, everybody, I hope that you have endured this crazy time in our lives well, and that you are, as always, that you're healthy and happy and doing well. And come by and see me when we're allowed to see people in person again. Come by my office and say hi. Let me know how you're doing. All right, everybody.